In question 1 of this exercise, we have to find the roots of all of these given quadratic equations by factorization. So the way we factorize a quadratic expression or a quadratic equation is by splitting the middle term. So how do we do that? So suppose that we have a quadratic equation ax square plus bx plus c equal to 0. So what we have to do to factorize is we have to split this middle term bx or this coefficient b into two parts, let's say p and q, such that p plus q is equal to b, the sum is equal to b, and p times q, the product, is equal to a times c. So this is how we have to split the middle term, and this is what we're going to do in this question. Okay, let's begin with part 1. So in part 1, the equation is x square minus 3x minus 10 is equal to 0. So what we have to do now is we have to split this middle term minus 3x such that the coefficients are, the sum of the coefficients is equal to minus 3 and the product is equal to 1 into minus 10 or minus 10. So the two such numbers whose sum is equal to minus 3 and whose product is equal to minus 10 are minus 5 and 2. So we'll split the middle term minus 3x as minus 5x plus 2x. So let's do that. So we will get x square minus 5x plus 2x minus 10 is equal to 0. And now this equation can be factorized. So from the first pair of terms, x square minus 5x, let's take out a common factor of x. So we get x times x minus 5. And then from the second pair of terms, let's take out a common factor of 2. So we get 2 times x minus 5 equal to 0. And hence this quadratic equation can be factorized as x minus 5 times x, this x plus this 2. So x plus 2 is equal to 0. And now we have factorized the quadratic into two linear factors. We can now easily write the roots of this equation. The roots of this equation are x equal to 5 and x equal to minus 2. So let's write the roots here, 5 and minus 2. So that solves part 1. Now let's do part 2. In part 2, the equation is 2x square plus x minus 6 is equal to 0. So to split the middle term, we have to find two numbers such that their sum is 1, the coefficient of x, and their product is 2 times minus 6 or minus 12. So those two numbers are 4 and minus 3. So we'll split the middle term x as 4x and minus 3x. So let's do that. So we will get 2x square plus x, which becomes 4x minus 3x. This is how we split the middle term, and minus 6 is equal to 0. Now we can factorize this equation. From the first pair of terms, we can take out a common factor of 2x, and that leaves us with x plus 2. And then from the second pair of terms, we can take out a common factor of minus 3, and that leaves us with x plus 2 once again. And now we can take out x plus 2, and that leaves us with 2x, this 2x minus this 3. This is equal to 0. So now we have factorized the quadratic into two linear factors, and now the roots are quite easy to write. So the roots are the 0 of x plus 2, so x is equal to minus 2, and the 0 of 2x minus 3, so x is equal to 3 by 2. So the two roots of this second quadratic equation are minus 2 and 3 by 2. So that solves part 2. Now let's go to the quadratic equation in part 3. So the equation in part 3 is root 2x square plus 7x plus 5 root 2 equal to 0. So to split the middle term 7x, we have to find two numbers whose sum is equal to 7, the coefficient of x, and whose product is equal to root 2 times 5 root 2, that's 10. So two numbers whose sum is 7 and whose product is 10, those two numbers are clearly 2 and 5. So we'll split the middle term 7x as 2x plus 5x. So let's do that now, and we will get root 2x square plus 7x gets split as 2x plus 5x, and then we have 5 root 2 equal to 0. Now from the first pair of terms, root 2x square plus 2x, we can take out a common factor of root 2x, and that will leave us with x plus root 2. And then from the second pair of terms, we can take out a common factor of 5, and that will leave us with x plus root 2 once again, and this is equal to 0. And now we see that this x plus root 2, this factor is common, so let's take this out. So we get x plus root 2 times this root 2x, so root 2x plus this 5, this is equal to 0. So we have managed to factorize the quadratic into two linear factors, and now finding the roots is quite straightforward. The roots will be x equal to the 0 of this first expression, so that's minus root 2, and x equal to the 0 of this second expression, which is minus 5 by root 2. So these are the two roots of the quadratic equation in part 3. So let's write them here, minus root 2 and minus 5 by root 2. So that solves part 3. Now let's go to part 4. In part 4, the quadratic equation is 2x square minus x plus 1 by 8 equal to 0. So what we can do to simplify this a little bit is we can first take an LCM of 8 across all the terms. So that will give us 16x square, which is 2x square times 8, and then minus x times 8, so that's minus 8x plus 1 divided by 8 is equal to 0. And now if we cross multiply the 8, we will get 16x square minus 8x plus 1 equal to 0. Now what you can note from this quadratic expression 16x square minus 8x plus 1 is that it is a perfect square, because you can write this as 4x whole square minus 2 times 4x times 1, and then this last term 1 can be written as 1 square, and this is equal to 0. So now if you observe this expression, it is of the form a square minus 2ab plus b square equal to 0. So we can factorize it as a minus b whole square. So we can write this as 4x minus 1 whole square equal to 0. So the two roots of this quadratic equation are actually identical, because the two linear factors of the quadratic are identical. So the two roots are x equal to 1 by 4 and x equal to 1 by 4, or we could say that the roots are identical. So let's write the roots here, 1 by 4 and 1 by 4. So that solves part 4. Now let's do part 5. In part 5, the quadratic equation is 100x square minus 20x plus 1 equal to 0. And once again, just like in part 4, this is actually a perfect square, because you can write it as 10x whole square minus 2 times 10x times 1, that's minus 20x, and then plus 1 square equal to 0. So if you look at this expression, it's of the form a square minus 2ab plus b square equal to 0. So you can factorize it as a minus b whole square. So 10x minus 1 whole square is equal to 0. And now we see that the quadratic factorizes into two identical linear factors. So the two roots of this equation are actually identical, and those two roots are x equal to, so 10x minus 1 equal to 0, or x equal to 1 by 10. and x equal to 1 by 10. So both the roots of this equation are 1 by 10. So let's write that here, 1 by 10 and 1 by 10. So that solves part 5, and with that all the parts of question 1 are done. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.